Okay, today I'm going to be teaching you about the exponential growth rate and the continuous model. Is P equals RT. This is the model. And the amount of A varies with the time T. This is the model that we're going to be following for this following problem right here. So let's suppose that the number of bacteria in a certain population increases according to a continuous exponential growth with a growth rate of 17% per hour. Let's also suppose that a sample culture of 2,500 bacteria is obtained in the population. So here we're trying to find the size of the sample after 2 hours. So this is our time. We'll see that in this continuous model, P is the amount of time where T equals 0. And R is a non-zero constant. And E is a natural logarithm base, unless specified otherwise, so this is just going to be E. And if R is greater than A, it increases over time, and we have an exponential growth rate. If it's less than 0, it's a decaying model. We're going to be doing a growth model. And something to note here is that although the growth rate parameter is 17% per hour, the actual growth is not 17% each hour. So our initial size of the sample is 2,500. That's P for the bacteria, and the growth rate parameter is R equals 17. If we make that into decimal, that's 0.17. And so let's use this information. We get the following. So A, if we just, from this point, we just plug into this equation right here. A equals P-E-R-T. So we have 2,500 E to the 0.17 times 2. And I actually have my calculator right here. And if you just count, oh, whoops, what just happened here? All right, if we plug in 2,500, and then we get E to a 0.17 times 2, boom, boom, bang, we get this number right here. And usually, when we do something like this, we want to round to the nearest integer. We're gonna take that, round this, and make it 3,512 bacteria, and this is the answer, and this is how you do a growth model.
Okay, now that we know growth, we're gonna do decay. So we have the equation, or the question, the mass of a radioactive follows a continuous exponential decay model with a decay of 2% each day. A sample of the radioactive substance has an initial mass of 3.69 kilograms. Find the mass of the sample after 5 days. So like Sam said, we're going to use the same equation, which is A equals P-E to the R times T. A equals amount after time. P equals initial amount. R equals exponential rate. And then T equals time. So for this equation, we're trying to figure out A. We want to figure out what was the decay. So A, we don't know what it is. P, which is the initial rate, is 3.69 kilograms. R, our rate is 2%, and our time was 5 days. So with this information, all we do is plug it in back into this equation. And then we get A is equal to 3.69 to the E times, we turn the 2% into something that we can work with math, and we put it to negative 0.02. We're doing negative because it's decaying, it's subtracting from what it originally was, times the time we want to figure out, which is 5 days. Then after that, we would multiply the negative 0.02 times 5, and that would give us negative 0.10. And then all we have to do is plug this into our calculator, and we'll get this number, 3.3388. And for this, we're going to round to our nearest hundredth, and then we're going to get our answer of 3.34 kilograms. So in 5 days, our substance will go to 3.34 kilograms, and it originally was 3.69.
All right, now we're moving on to half-life. So suppose you have 56 kilograms of an element. If its half-life is every 5 days, how much would remain at T equals 15 days? So using the same formula as growth rate and decay. But first you have to find the rate. So we know after 5 days is what we have. So half of 56 is 28. So you set that up with using the formula 28 equals 56. It's E to the negative 5k. First you isolate the exponential. So you get 1/2 equals E to the negative 5k. Then you apply natural log to get rid of the E, and you get the natural log of 1/2 equals to negative 5k. You simplify ln, so you get -1 natural log of 2 equals -5k, and then you just solve for k. You end up with natural log of 2 over 5 is equal to the rate. So now you apply that to the 15-day thing, and then you get 56 e to the negative ln of 2 over 5 times 15. So now you're gonna have to cancel out the exponential by removing the 5, applying it to the outer 15, and you cancel out the e to the ln, so you get 56 to 1/2 to the third power, which is essentially just 56 times 1 to the 8th, which is equals 7 kilograms.
Bang, bang, bang.
And that's it.
Pretty good.
Math boys.